All right, everybody. So here we are in topic 6, DQ1. All right, we are going to do a little bit of work with some random numbers. We have a random number generator in columns C and D. We're going to look at some probabilities and some deviations. Let's check our goals out here just a moment. We want to learn how to use autofill, theoretical probabilities, compute probabilities for events, using counting, empirical probabilities, investigate how the empirical probabilities and theoretical probabilities are related. All right, let's look at this. All right, so in column A, we want to take a look at the number of rolls in our columns C and D. Column C, we're going to have 1,000 rolls. Column D, we're going to have 4,000 rolls. All right, so what we want to do is write a formula that counts for us right here. So I'm going to do column C. I'll let you guys do column D, okay? So we want to count, that is equals count. I want column C, so I would do C colon C. All right. What would you guys do for column D, right? Obviously, not the same thing. You got this. All right. So hit enter. And you can see that I have one number here. Let's pull this down a little bit, right? Lower right-hand corner, just drag and see. All right, now it counted 12. All right, so the function is properly set up. So I'm going to drag this all the way down to 1,000. All right, it goes pretty quickly. When you do 4,000, you don't have to drag all the way down. You can right-click the lower right-hand corner, double-click it, not right-click, double-click the lower right-hand corner, and it will fill all the way down. But there are 4,000 rows in this, and I can't do 4,000 for column C. So I'm just dragging and talking while I'm dragging, right? We're almost there. All right. So there you go. I'm going to get back up to the top quick. Just right-hand side, pull it back up. All right. There we are. All right. So all that is done. Next, everybody, I want to do the empirical probability. Now, the probability in every single instance, everybody, is the number of outcomes that you're looking for divided by the total number of outcomes, all right? That's the probability as a percent or a decimal, whichever you want to get it, okay? So probability of any event E is the probability of event E divided by the total number of outcomes in your set. So in this case, in cell H4, you can see my frequency in column G is 77. 77. So what would I do? I would start my formula with equals. Then I want the number of items in column G, right? And column G, that is cell G4 at the moment, divided by the number of items that I just counted in column C. Where's that value, everybody? Right. It's in C7. All right. So there's my formula. Now I'm going to lock this formula, right, with the absolute value so it doesn't move down, right? You guys have been doing this for a minute now. All right, I'm going to lock that so I can drag it down. And now watch what I can do. I can just pop it all the way down, left click, double click. Oh, it says you can't do that. Okay, just drag then. Just drag it down. And there you go. All right, you guys can see this is a self-correcting Excel sheet, so it turns green with a gray background when correct. We're good to go. Theoretical probability, everybody, is simply the theory about behind what would theoretically happen, okay? So every single die has an option of showing up one time, right? So you guys can see here, actually, I'm going to delete a couple of these down here just to show you guys, okay? I'm deleting these because I don't have any values in these cells. You can see I have 12 rows here. All right, you got to choose some number you guys want over there, some number between 1 and 15, right? I chose 12. All right. So now back to theoretical probability. Theoretical probability is 1 divided by the number of possible outcomes on your die. In this case, the die is 12-sided, so I would simply type equals 1 divided by the cell where that number is, okay? And it's cell A4. Go ahead and lock that in. So you can drag it down, hit enter. When you do that, the difference, the deviation is going to automatically populate, okay? So the deviation automatically populates. Do pay close attention to these up here, everybody. Notice. Empirically, in other words, in my experiment, I didn't get anything exactly a 0.083, a 0.084. Some of them were pretty close, but you can see they deviate by up to 7/10,000ths, right? And you can format those to a percent if you want to. You can leave them like that if you want to. It doesn't matter to me. All right, next we want to go ahead and we want to find the average of the deviations, everybody. How would I find the average? You've done that more than once by now, so equals average. All right, and then just find the data that we're working with here, right? Whoops, that is not correct. Let's try this one more time. My mouse kind of moved on me here. There we go. Close parentheses, hit enter, and you've got it. There's the average. So the average was 6.9 thousandths, right? 6.9 thousandths. Not bad at all, right, everybody? All right. Now at this point, everybody, I have done the top one. I want you to do the second one. That is the number of rows in column 2. Be careful, there are 4,000, so be sure you take it all the way down to 4,000, okay? Then go ahead and complete the table 2 with the empirical and the theoretical probabilities for the roll of 4,000. Complete the deviation, the average deviation, just like I did in the above. And then make sure you come over here and everybody take a look at, compare the difference between the 1,000 and 4,000 rolls. What do you think would happen if you were to roll more? Okay. So notice these deviations right here. Let me show you. These deviations, pay close attention to those, and the ones you get down here, pay close attention to the average deviation. And notice, is the deviation lower when I have more rolls? Okay, is it lower if I have more rolls? And what do you think would happen if I rolled more and more? Okay, I'm gonna let you guys think about that as you do this assignment. All right, very good, everybody. We have wrapped this one up. Thank you guys. Take care, and I'll see you in the forums.